Welcome to This Explainer. Right now, we're essentially watching the most high stakes collision of our modern era. On one hand, you have the limitless, awe inspiring, and honestly, sometimes completely chaotic capabilities of artificial intelligence. And on the other, the incredibly strict, heavy steel guardrails of global regulation, which are rolling out a whole lot faster than anyone really expected. Today, we're pitting the raw, revving engine of large language models directly against the brand new EU AI Act. So let's just dive right into this dichotomy with our main question. How exactly do we govern a machine that we are fundamentally still learning to understand ourselves? Because that's where we're at, right? We're caught in this crazy tension between the raw statistical power of these emerging technologies and the absolutely necessary societal response to keep them safe. But look, to really grasp why these new laws are being written the way they are, we first have to pop the hood and understand the machine they're actually trying to regulate. Section 1. The Language Model Engine. Popping the hood. Think of the journey from a prompt to a complex prediction, basically like the internal combustion cycle of an AI. First up, we have tokenization. The model takes billions of words from books, articles, code, the whole shebang, and breaks them down into smaller, machine-readable units called tokens. This is the raw fuel. Next, we embed. Every single token gets mapped to a vector of numbers, giving it a very specific location in this massive mathematical space where words with similar meanings are naturally grouped together. It builds context. And finally, we hit the steering mechanism, self-attention. Using query, key, and value vectors, the model calculates the relationships and dependencies between all of those tokens at the exact same time. It's a brilliant setup that allows the model to flexibly focus on the most relevant context while just completely ignoring all the background noise. But if we strip away the magic and the hype for a second, what do we actually have? Well, at its absolute core, a large language model is simply a giant statistical prediction machine. That's it. It repeatedly predicts the next word in a sequence based entirely on the patterns it learned during training. It doesn't actually know the final answer before it starts typing. Instead, it evaluates all those statistical relationships and just spits out the most likely next token, making its absolute best guess, step by step by step. So then, how do we transition from those raw statistical engines to the incredibly helpful conversational bots that we're using every single day? Because a raw model really just wants to finish a pattern, but an AI assistant, it actually needs to follow instructions safely. That's exactly where techniques like instruction tuning and reinforcement learning from human feedback, or RLHF for short, come into play. Humans literally sit there and rank the model's outputs. They act as a fine-tuning steering wheel that trains the AI to prioritize responses that are helpful, consistent, and above all, safe. Section 2. The flaws in the machine, risks and limitations. Now, we really have to weigh the immense utility of these tools against their real-world flaws. On the capability side, we're talking about mind-blowing power, generating complex code across multiple programming languages, translating obscure texts, and utilizing chain-of-thought reasoning to break down massive problems. It's a real game changer. But then, look at the limitations. Because it's purely statistical, the machine suffers from hallucinations. It can and will generate completely false information with absolute terrifying confidence. It can also easily amplify historical biases that were just sitting there in its training data, producing outputs that are genuinely unfair. And as these models scale up, they pose broader systemic risks, eating up massive amounts of computational power and energy. This exact contrast, right here, this is what makes regulatory breaks an absolute necessity. Section 3. Enter the EU AI Act, the traffic lights. And this regulatory framework isn't some distant, theoretical sci-fi future. It is a definitive legislative timeline that is rolling out right now. The act officially entered into force in August of 2024. By February 2025, the prohibitions on unacceptable risk AI systems become fully enforceable. By August 2025, the rules for general-purpose AI models kick in. By August 2026, obligations for high-risk systems take effect. And finally, by August 2027, full compliance is mandatory across the board. So these are the new regulatory speed limits, and the clock is very much ticking. Section 4. The 4 tiers of risk, categorizing AI. The core philosophy of the EU AI Act is a proportional, risk-based approach. The crucial thing to understand is how the law actually categorizes that danger. They've divided AI into 4 distinct tiers. At the very top, we have unacceptable risk, and this is just outright banned, no exceptions. We're talking things like government social scoring or intentionally exploitative AI. Next down is high risk. These are heavily regulated applications, like using AI for CV screening and hiring, or managing critical infrastructure. Then we hit limited risk, which basically just demands transparency. Think of deepfakes or your standard customer service chatbots. Users simply must be told they're interacting with an AI. And finally, minimal risk. This is your standard email spam filter or the AI enemies in your video games, and these are basically left alone. As you might guess, the vast majority of the regulatory heavy lifting happens right there in that high-risk tier. If an organization wants to deploy a high-risk system, the mandatory guardrails are incredibly strict. And we aren't just talking about a bit of extra paperwork. They have to establish a continuous risk management system and ensure really high-quality, unbiased data governance. They're required to maintain automatic logging of events, so there's always a traceable history. On top of that, they have to conduct fundamental rights impact assessments, and crucially, this is the big one, they must design the system so a human can always pull the plug. A human essentially has to be able to intervene, interrupt, or completely override the AI's decisions at any given time. Section 5. Compliance and consequences. Who is responsible? The EU AI Act casts a really wide net here, creating a fairly complex web of responsibilities by defining some very specific roles. You have the provider, that's the organization actually developing the AI system. They bear the primary compliance burden, like all the initial testing and documentation. But then you also have the deployer, the organization that's actually using the AI system in the real world. Think of it like this. The provider is the one who builds the engine, and the deployer is the one driving the car. But it doesn't stop there. Importers and distributors are also on the hook to actively verify compliance before these systems ever hit the European market. So what happens if these roles fail to meet those obligations? Well, the financial stakes are frankly monumental. If a company violates the prohibitions on unacceptable risk AI practices, say by deploying real-time biometric surveillance in a public space or setting up a social scoring system, they can face a maximum fine of up to 35 million euros. Or, and this is where it gets truly staggering, they can be fined up to 7% of their global annual turnover, whichever number is higher, even for lesser violations, like just a lack of transparency around deepfakes. Fines can still reach 7.5 million euros. These are definitely not gentle nudges from regulators. These guardrails are made of solid steel, and they are very clearly designed to force global compliance. Ultimately, we are witnessing a head-on collision between the fastest-moving technology in human history and the absolute most comprehensive regulatory framework ever drafted. So I'll leave you with this to chew on. As these statistical prediction engines continue to grow infinitely more complex and powerful, will these rigorous legal guardrails succeed in keeping our society safely on the road, or will they ultimately stifle the journey of innovation entirely? It's a massive question, and it's one that every single developer, deployer, and user is going to have to answer in the coming years. Thanks so much for joining me for this explainer, and keep questioning the technology that's shaping our world.